Welcome! And hey, if you've just wrapped up phase one, a huge congratulations. You are more than ready for this. Today, we are going to dive into descriptive statistics, and I promise we're going to make it clear, super practical, and maybe even a little bit fun by showing you exactly how it connects to the real world. So this session comes to you with thanks to the Department of Data Science and Economic Policy at the University of Cape Coast. And you know what? This is it, the official start of phase two of your program. In phase one, you learned how to handle data. Now we're going to learn how to reason with it. Let's get right into it. I want to kick things off with a little question for you. Just think for a second about three very different people going about their daily lives right here in Ghana. You've got a trader in the middle of that bustling Kejetia market, a lecturer right here on campus, and a district officer who's managing local affairs. What on earth could possibly connect all of them? Well, the answer is they all use statistics. And I don't mean just once in a while. I mean every single day. And that is the big idea I want you to take away today. Statistics is not some strange, abstract thing from a textbook. It's a way of thinking that you and they already use. So what we're going to do is see how descriptive statistics really just gives us a clear, precise language for the kinds of judgments that people are already making all the time. Let's look at some real examples. So imagine that trader in Kumasi. It's the end of a long, tiring week, and she's thinking back, what was the usual price for a box of tomatoes? Not the highest price she got, not the lowest, but what was the most typical? And that simple, everyday question, that's a statistical one. In her head, she is calculating the median, that middle value that really represents a typical day's business. Okay, now let's think about a lecturer at UCC. They're looking over a pile of quiz results. They might scan that list and ask themselves, all right, what was the most common score here? Which grade did most of the students actually get? Yep, you guessed it. That's a statistical question too. The lecturer is looking for the mode, which is just the value that pops up most often in the data. And finally, let's check in with our district officer. They're looking at the rainfall numbers for, say, June, and they need to figure out if it was a really rainy month. To do that, they have to compare it to something, right? A baseline of some sort. And to answer that, what they do is compare this month's rainfall to the average, what we call the mean, for June over the last 10 years. So you see, mean, median, and mode, they're not these scary foreign ideas. They are just precise words for the kind of thinking we all do every day. So now that we know statistics isn't some weird new language, let's learn our first really powerful command. In Python, when you use the .describe command, you get an instant statistical profile of your data. It's like a super fast, detailed summary of everything you've got. Okay, here it is. This is what the .describe command gives you when you run it on our Cape Coast rainfall data. Now, I know what you're thinking. That looks like a lot of numbers all at once, but don't worry about it. We're going to break this down line by line and see exactly what each of these rows is telling us. Let's just walk through this together. First up, count. Simple enough, right? It's just the number of observations we have, in this case, 12 months of data. Then mean is the good old average, about 84.6 millimeters. Min and max show us the range, from the driest month at 41 millimeters to the wettest at 129. Then you have these quartiles, the 25, 50, and 75% points, which just slice our data into 4 equal chunks. That leaves just one mysterious one, STD, standard deviation. So what in the world is standard deviation? Let's forget about formulas for a second and just use a simple story. Imagine a class quiz. If every single student scores between 68 and 72, the scores are really bunched up, they're tightly clustered. The standard deviation would be small. But if the scores are all over the place, from a 30 all the way up to a 95, they are widely spread out, and the standard deviation is going to be large. So for our rainfall data, a high standard deviation makes perfect sense, doesn't it? It just reflects that huge difference we expect between Ghana's wet and dry seasons. Okay, so we've talked about the mean, the average, but it has this close cousin called the median. And honestly, knowing when to use one versus the other is a really crucial data science skill. Let's dig into this with a little story, a tale of tomato prices. So have a look here. We've got the weekly price for a box of tomatoes. And you'll notice for the first 7 weeks, that price is pretty stable, right? It's hovering around 20 Ghanaian cedis. But then in week 8, something big happens. Maybe there's a problem with the supply, and the price just shoots up to 65. Now, watch what this one weirdly high price does to our numbers. The mean, the average, gets pulled all the way up to almost 27. But the median, it stays much closer to what you'd call a typical price, down at 21.5. So, which one is right? Well, it's a trick question. They both are. They just answer different questions. The mean is heavily influenced by that one expensive week. It's super useful if you want to calculate, say, the total amount of money spent over all 8 weeks. But the median is resistant to that extreme value, that outlier. It gives you a much better feel for a typical week's price. So the big takeaway here is this: the right statistic always depends on the question you are trying to answer. Up to now, we've been describing a whole column of data at once. But, a lot of the time, the most interesting insights come from comparing different groups within that data. And for that, we have another fantastic tool, Group By. So let's imagine we're looking at attendance records for a class. We can use Group By to quickly calculate the average attendance for students from each program. Now, at first glance, you might look at this and say, oh, it looks like the economics students have slightly higher attendance. But wait a second. Before we jump to any conclusions, I want you to look at the column right next to it, the count. This right here is one of the most important habits you can build in data analysis. Always check your group size. See that? The average for public admin is based on just 2 students. That tells a much weaker story than an average that was based on, say, 40 students. This is such a critical check. You have to look at the count. Okay, we have learned how to calculate some pretty cool numbers, but the final, and I'd say most critical step, is learning how to talk about them. This is what we call the interpretation discipline. It's all about being precise, being cautious, and being honest about what our data can and cannot tell us. Now, these might seem like really small changes in how you phrase things, but I'm telling you, they're the entire difference between responsible analysis and dangerous overstatement. We never say something is always true. We say it's true in this data set. We don't claim our data proves something, we say it suggests it. This isn't about being weak or unsure. It's about being accurate and building trust in the work that you do. And why does this matter so much? Because these statistics are actually used to make real-world decisions. Think about it. If you're a district assembly and you're worried about flooding, you don't really care about the mean rainfall. What you care about is the maximum rainfall. If you're monitoring market prices, you need both the mean and the median to get the full picture of typical weeks and those unusual spikes. It all comes back to this. The right statistic depends entirely on the decision you're trying to support. All right, let's just recap for a second. You can now take a whole column of numbers and create a full statistical profile. You can explain that crucial difference between a mean and a median, and you know how to compare groups responsibly. You now have the foundational language of data description. So what's the next logical question? Well, it's all about relationships. Do 2 things tend to move together? And that is exactly what we're going to tackle in session 6. I can't wait to explore it with you next time.